In this video, I'm going to talk about everything about simultaneous equation, especially related to linear function. Firstly, let's think about why we use simultaneous equations. The reason why we use or apply the simultaneous equation in this situation is because we want to find the intersecting points between graphs or functions by solving the x input and y output values in our way coordinates on the coordinate plane that satisfy both functions. Therefore, the answers, which we call it or notated as the solutions of simultaneous equations, will be the intersecting points coordinates. Now, secondly, let's think about our main rules when it comes to using these simultaneous equations. Firstly, our main priority as a step of using and applying our simultaneous equation is to remove the variables in an order, because we'll be facing various kinds of complicated variables in the equations that must satisfy the functions, and that means we can only use it when we have enough information. So the information will going to be the quantity between the given equations, and the variables should be exactly equivalent. There are three main and general ways in the simultaneous equations. Firstly, method of addition and subtraction. Secondly, method of substitutions. And lastly, the method of equivalence. There are the three general ways when it comes to using or applying all simultaneous equations to solve our solutions. And again, solutions in the simultaneous equations will going to be the intersecting points coordinate between two or three graphs or functions. And today I'm going to explain all of them using one simple example as well as steps, and in the next video we'll be facing variety kinds of real-life advanced functions, especially simultaneous equations. Firstly, let's think about the method of addition and subtraction. Basically, it is a method to solve the solutions in the simultaneous equations using arithmetic and remove variables in an array by adding or subtracting both equations properly according to the possibilities, and solve one variable and substitute it back to our original function to solve other. And here is a step for the method of addition and subtraction. Firstly, multiply each equation by a suitable number so that the two equations have the same leading coefficient, and obviously the two equations have the same leading coefficient, which means the coefficient of one of the variables, that can be either x or y, should be same. Next step, we're going to be subtract or add, which means use arithmetic to the equations and solve for one variable. If we solve for one variable, obviously we can substitute it back to our original function to get our complete solutions. This is a method of addition and subtraction. Secondly, the method of substitution. It is a way to solve the solutions of simultaneous equations by making one equation into a specific function and input that function back to our original another function to solve for the other variables. And here are some three general or specific steps for applying our method of substitutions. Firstly, isolate one of the variables that can be either x or y, depends on times or situations. Isolate it on one side of one of the equations. Then substitute for the isolated variable in the other equations. And lastly, solve for the equation for the other variable. And that will going to give us x and y in our way solutions in our simultaneous equations. Lastly, the method of equivalence. As we can see through our name or the title of our method, we are same thing with making the both equations into equivalent. And here are the ways to apply it. Firstly, make equation into the same variable by isolating other terms into the other sides, which means the variable can be either x or y, depends on times. Secondly, then two functions will going to be equivalent, as we can see, and one variable will be isolated in another. Then solve for the variable and input it back to the original function to solve for the complete solutions. And here's the way to apply the simultaneous equation in the method of equivalence. And now let's apply this general facts of three methods of simultaneous equations through our two basic examples of simultaneous equations. Here is one super basic example of the simultaneous equation that we can prove with three methods. Firstly, method of addition and subtraction. Secondly, method of substitution. Thirdly, method of equivalence. Before we start, we remind ourselves the most important rule or priority when it comes to solving or applying the method or the simultaneous equation is that we need to remove the variables in an order in order to solve for the solutions or the complete solutions, which eventually will going to be the intersecting points between coordinates. And now these two things will going to be the linear function, which means when you convert it into a graph, it will going to be a straight lines. And we're trying to solve for the x and then y value, which means the coordinates that satisfy these two function, and that will going to be the intersecting points. So first of all, let's apply our first method of addition and subtraction. The most important thing in the method of addition and subtraction is that we need to add or subtract both equations in order to solve for the variable. So first of all, let's write our two equations down. 2x plus y is equal to 3. And another one, x plus y is equal to 2. And we can know that this was going to be a super basic example for simultaneous equation just to prove these three methods. So we need to think about how to add or subtract. Should we add or subtract both equations in order to get other variable? And if we're not, in the worst case, we need to multiply each variables into some specific numbers in order to solve or make the coefficients exactly same. But in this case, luckily, if we just subtract it, the y values will gonna be removed easily. So all you have to do in this case will gonna be subtracted. And we're going to get 2x minus x will going to be x. And then y minus y will going to be 0. And that is equal to 1. And since we've solved for the x value, which will going to be the input, so the x value will going to be the input of our function. And since we solved the input, all you have to do is we need to input this back to our original function, either one of them, because this one satisfies both functions. So therefore, let's add this to x plus y is equal to 2 because it looks simple. So there's x plus y is equal to 2. If we input x as 1, we're going to get 1 plus y is equal to 2. And then when you isolate the y value on the left side, we're going to get y is equal to 1. And we can actually prove it. So let's input 1 into first one. By the way, we could say that this coordinate we're going to be 1, comma 1, which means this one should satisfy both functions. So let's actually prove it. So the first one, the output of our function, which we're going to be our y value, is 1. And that should be equal to when you input x value as 1. But in this case, 3 will going to be the output. And that is equal to 1 as the x value plus y value as 1. This indeed equal to 3. And let's think about the second one. And when the x value is equal to 1, and then y value is equal to 1, and that should be equal to 2. So we could say that this coordinate should always satisfy our two equations. And that is the first way how we solve the simultaneous equations through the method of addition or subtraction, but in this case we used subtraction. And let's go to the second method of our addition of our simultaneous equation, the method of substitutions. So again, the most important thing when it comes to solving or applying our method of substitution is that it is a way to solve the solutions by making one equation into a specific function and input it back to the original function to solve the another. So first of all, let's write our two functions down again. 2x plus y is equal to 3. X plus y is equal to 2. I'm going to prefer the second one because it looks really simple. And all you have to do is we need to make this into some specific function. And since we knew that it is a linear function because there is a first degree power in the x terms, we can convert this into a standard form of our linear function. And that will going to be y is equal to 2 minus x. And we could know that this one is exactly the same thing with this one, except we convert this into a specific format of function. And now we can use our substitution rule, which means we need to substitute our function back to our original function, another function, in order to solve for our one variable. And most important when it comes to applying our simultaneous equation is that we always need to remove the variables. If we apply it, we're going to get 2x plus y, but instead of y, we inputted 2 minus x. So it will going to be 2 minus x, and that is equal to 3. All we did is we inputted back our y value into our y value. The reason why we could do it is that we figure out that y value and our y value is exactly same. Only way that we can apply our simultaneous equation is that if the y or the variables are exactly equivalent. So from here, all we have to do is simplify our expressions. We're going to get 2x and then minus x plus 2 is equal to 3. We'll get x is equal to 1. Since we solved our x value, which will going to be our positive 1, and this will going to be the x coordinate of our intersecting points, all you have to do in order to solve our y value, which will going to be the output of our function, is to input this back to our original function. So let's input it to our first function. 2x plus y is equal to 3. When you input x value as 1 to our original function, instead of x, we input 1. And we're going to get 2 plus y is equal to 3. And if we isolate the y value, we can get y is equal to 1. So we solved the y value, and this was the method of substitution. So for total, like a conclusion, we could say that the intersecting points coordinate will going to be x1, comma y1. And we could obviously compare that this is exactly the same with the method of addition and subtractions answered. Lastly, let's think about the method of equivalence. The most important thing when it comes to solving for a method of equivalence is to make two equations into some specific function. Method of substitution was just making one simple equation into some specific function and input it back to the other equation. But in this case, we're inputting or making every single equations into a function. Which means let's write our function down again. Our first equation was 2x plus y is equal to 3. And the second one was x plus y is equal to 2. And now we need to make every single equations into some specific function. And the function means should be always consist of y and x input and output value. So if we convert first one into a function, by isolating every single term into right side and the y value left side, we're going to get y is equal to 3 minus 2x. The second one we're going to be y is equal to 2 minus x. All we did is we converted every single equation into some specific function. Now it's time for us to solve or apply our method of equivalence. Since we knew that this one is also y and this one is also y, which means eventually this 3 minus 2x and 2 minus x is same because they're both y. And this will going to be the method of equivalence. So we can eventually make that 3 minus 2x is exactly the same thing with 2 minus x. We removed y value, which will going to be the variable, and we got only one variable left, which will going to be our x value. So all you have to do is we need to isolate our x terms on the left side and our constant right side. And we're going to get, if we add it, we're going to get minus x is equal to minus 1. All you have to do is divide -1 to the both sides in order to get our x value, which we're going to get 1. So we solve for our x value through our equivalence. And all you have to do in order to solve for a y value is substitute it back to our original function. Let's substitute our simplest one, which we're going to be x plus y is equal to 2. Instead of x value, we input 1. We could get that y is also equal to 1. So when x is equal to 1, our y value should always be equal to 1 too. So our coordinate will going to be 1, 1. And this whole thing's will going to be the intersection point between our two linear functions. So if we review what we did here, method of addition and subtraction. Before we do it, the most important thing when it comes to applying our simultaneous equation is that we always need to remember where we need to remove the variables in an order. Method of addition and subtraction. We need to think about how to add or subtract both functions in order to get or simplify, remove one variable so that we can get one variable, and if we solve for it, we need to input it back to get the other variable. And we got our answer. Our coordinate was 1, 1, which means the intersection point between two linear functions was 1, 1. Secondly, the method of substitution. All we did is we converted one equation, simplest equation, into a function. And after we did it, we input it back to our other function, which because only reason why we could do it is because the y value and the y value was exactly equivalent. And after we solved for it, we input it back and we got our output, which was our y value as 1. So our function's coordinate was 1, 1 also. Lastly, method of equivalence. Only difference between the method of substitution is that in the method of substitution, we made only one equation into function, but then in the method of equivalence, we made both of them as the specific function. And eventually, they were going to be exactly equivalent since that they're y's. So we did it and we removed our one variable, which was y, and we solved for our x value. We input that back to the simple function back in order to get the other output, y. So we could say that it was 1, 1 as the answer. And in the next videos, we're going to talk about various kinds of real-life advanced simultaneous equations problem.